Alcohol is a solution. It's a solution of ethanol dissolved in water. So the solute is ethanol and the solvent is water. And there are different ways that alcohol gets packaged. So you can get vodka, which is 40% ethanol dissolved in water. So if there are 100 units of the total solution, 40 of those units would be ethanol. In beer, it's an ethanol solution as well, but there's a lot less ethanol. The concentration is a lot lower. So in this beer, there's 7%. It's 7%. So meaning that of 100 units, only 7 of them would be ethanol. And so you would know that if a person was drinking alcohol and they wanted to monitor their consumption and kind of pace themselves, if they were consuming beer like this, that's 7%, they would be able to consume more of the total solution than if they were consuming vodka. And that's why vodka would often be diluted before it's consumed. It's not as often consumed at the full strength of 40%, because that means that the amount that you can consume is quite small. Whereas beer is typically not diluted because it's already not particularly concentrated. And even amongst beers, if you have a beer like this is a beer that has 7% ethanol. You can compare that to a beer that has 4.5% ethanol. And the 4.5% ethanol is a weaker beer, meaning that it has less alcohol, has less ethanol in the total solution. And so those are examples of solution concentrations measured in percent concentration. And you'll see that for alcohol solutions, but also a lot of other household products, because it's a fairly intuitive method. Vinegar in my cupboard is 5% acetic acid by volume. So of 100 units, 5 of them will be acetic acid units. And we can compare that to pickling vinegar, which is 7% acetic acid by volume. So it's a stronger solution of acetic acid. And again, both of those ideas, 5%, 7%, they kind of make sense to me because I have an idea of what a percent is. So if we want to calculate percent concentration, we will often do it as percent by volume. So we would call this percent by volume, where I'm measuring out an amount of solute as a volume, and I'm also measuring the total solution as a volume as well. So that means that I've got a volume of solute, right, the thing that is dissolved, in a total volume of solution. I take the solute divided by the solution times 100 to turn this into a percent. Now, these are volumes, so we need to have volume units, such as liters or milliliters. And it doesn't actually matter what unit I use for the volume of solute and the volume of solution, but what does matter is that the volume units must match. So the units here must match. So if you use milliliters, then you have to use milliliters for both. Or if you use liters, you have to use liters for both. You could use peak liters or megaliters if you want, but these are the most common 2 units that we'll use. And so this is what we would do if we measured my solute as a liquid and my solution as a liquid, and we're measuring them both by volume. So that would make sense for something like an ethanol solution, where the ethyl alcohol is a liquid, the water is a liquid, so the total solution is a liquid as well. So it makes sense to measure them both by volume. It's an easy way to do it. Sometimes for solutions, though, we might measure them by mass instead. This might be true for things that we're dealing with really large quantities, and it's easier to weigh them than it is to measure the volume of the substance. And so this gets written as percent W over W, so percent by weight, but chemists are still a little bit confused about the difference between weight and mass, and so this is actually percent by mass. And as you might guess here, if we're measuring these not as volumes but as masses, then we would have to take the mass of my solute divided by my mass of my solution, again times 100, and just like before, the units must match. So if I use grams on the bottom, I have to use grams on the top. If I use kilograms on the bottom, I have to use kilograms on the top, etc. Seems to make pretty good sense. Now, the last type that we're going to talk about is percent by weight over volume. And this type we might use if we're making something like a sugar solution. So I'm dissolving sugar in water. Now, the sugar is easiest to weigh as to weigh the mass of the sugar, right? To take the mass, because it's coming as a solid, and weighing solids by volume is not particularly accurate. That's the reason why professional bakers weigh their things instead of like their flour and their sugar, instead of using measuring cups, which measures by volume. So we take the mass of the solute, but we're going to take the volume of the total solution. And so we have the mass of the solute here divided by the volume of the solution. Again, times 100. Now, what you have to watch here, this is the trickiest one with units, because the units are going to be different, right? We've got a mass unit on the top, we've got a volume unit on the bottom. What we have to remember here is that for water, which has a density of 1, it's not that 1 gram equals 1 liter. That's the base unit for mass and the base unit for volume, with no metric prefixes, gram and a liter. But a gram and a liter are not the same size. If you think about a liter of pop, it doesn't weigh 1 gram. A liter of pop weighs, or a liter of water weighs 1,000 grams. And so that means that a kilogram is actually the same size as a liter. Or if you're weighing the solid solute in grams, which we would often do, then you would have to weigh the solution in milliliters, because a gram and a milliliter are the same size. So these are the pairings that you have to use. If you use the solute in kilograms, then you have to measure the volume of the solution in liters. Or if you use grams for your solute, then you have to use milliliters for your solution. Because for water, and then we can assume for dilute solutions as well. So for the solutions that we're going to use in Chemistry 20, that the densities here will match. So let's try an example. A lot of the gasoline that you buy at the pump these days is not gasoline, it's actually gasohol. And gasohol is a solution of ethanol and gasoline. So ethanol is the solute, and gasoline is the solvent. So if we have a typical gasohol mixture, which contains 4.1 liters of ethanol, so that's a volume of solute, in a 55-liter tank. Now that's my total solution, right? Because the whole thing's got to fit in that tank. So that's my V solution. What's the percent by volume ethanol in the solution? So let's go to my formula. The percent by volume is going to equal my V solute divided by my V solution times 100. I know my V solute, which is 4.1 liters. I know my V solution, which is 55 liters, and I'm looking for my percent concentration. So I don't need to rearrange my formula. I can plug in. My V solute is 4.1 liters divided by 55 liters times 100. I'm making sure to put my units in here because if they don't match, I have to convert one of them so that they do match. And putting my units in helps me catch that. So 4.1 divided by 55 times 100. My calculator says 7.4545. I get 2 sig digs here. So we're going to round that to 7.5% by volume. So that would be my final answer. That's the percent by volume ethanol in the gasoline. Now let's try another one. Sterling silver is 92.5% by weight, by mass. Pure silver. If a silver chain has a mass of 200 grams, what is the mass of pure silver present in the chain? So here we're going to treat the pure silver like my solute. And the sterling silver is the total solution. So I'm looking for my mass of solute. My 200 grams is my total solution. And then I know my concentration. So my percent concentration by mass is 92.5%. So then the formula that I'm going to use this time is this version, the percent by mass version of the formula. So let's start by writing it out. Percent weight over weight is equal to my mass of solute divided by my mass of solution times 100. I need to get M solute by itself. So that means I need to clear these things out. Let's start with the 100. So to get 100 to cancel, I need to divide by 100 on this side, divide by 100 on this side. Those guys are going to cancel. And then to get my M solution to cancel, I need to multiply by M solution on this side, multiply by M solution on this side, and then it divides by itself, and it will cancel. So my new formula is M solute. So my new formula is M solute is equal to M solution times the percent by weight divided by 100. Now we can plug in our numbers. The mass of my total solution was 200 grams. The concentration was 92.5%. And then divided by 100. And that gives me 185. I get 3 sig digs here. So 185 grams of silver. So that's the mass of pure silver present in the chain. And here's an example of a solution made of 2 solids, right? The silver and the other elements were mixed together and then allowed to cool. And then let's do one more example here. In a 5% weight over volume glucose solution, what mass of glucose would be contained in 500 milliliters of total solution? So this is my total solution. I'm looking for my mass of glucose. And this is my concentration. Okay. So the concentration is 5% weight over volume. My mass of solute is what I'm looking for, and my volume of solution is 500 milliliters. So now I need to use my mass over volume version of the formula. So the percent weight over volume is equal to my M solute divided by my V solution. Don't forget about the times 100. So to get M solute by itself, I need to divide by 100, both sides, and then multiply by V solution. Multiply by V solution. Those guys will cancel there. So then my M solute is equal to V solution times my percent divided by 100. We can plug in our numbers. So my V solution was 500 milliliters. My percent was 5% divided by 100. That gives me 25 somethings. Now, we would have to round this here to only 1 sig dig, so we'll do that in a minute. But first, let's think about the units. So this is my mass of solute, and the unit that comes out is going to be a mass unit, so like grams or kilograms, and it's going to depend on the volume unit we plugged in. We plugged in milliliters for my volume of solution, so that means that this guy then is going to come out not in milligrams, but in grams, because a gram is the same size as a milliliter. Now, I'm only allowed 1 sig dig, though, so that means that I could put this into scientific notation, move the decimal up 1, and that would give me 3 times 10 to the power of 1 grams. That would work. Or I could also put this into kilograms. So if I divide by 1,000, that would give me 0.025 kilograms, which I could round to 0.03. That would also have only 1 sig dig, so that would be an acceptable way to record my answer as well. Either of these would work because they've got the right number of sig digs. Now, to practice, you can take a look at the practice assignment. You have some percent questions down here at the end. Give them a try and ask me if you have any questions.